All right. This whole chapter, chapter 3, is for quadratics. At least the first 2 or 3 sections. And a quadratic is a 25-cent word for the 25-cent word for a parabolic function. Okay? Ax squared plus bx plus c. That is a quadratic equation. Well, it's a quadratic expression. This is a quadratic equation. Or f of x is equal to ax squared plus bx plus c, or y is equal to x squared, ax squared plus bx plus c. All of these are quadratic equations. Now, there's 2 or 3 things we want to find with a quadratic equation. One, we want to know what the y-intercept is. 2, we want to know what the x-intercepts are. 3, we want to know what the vertex is. 4, we want to know what the line of symmetry is. And 5, we want to know domain, range, increasing and decreasing values. You might want to write those words out so you don't forget. Y-intercept, x-intercept, vertex, line of symmetry, domain, range, increasing and decreasing values. Now I listed the y-intercept first. The reason I listed the y-intercept first is because it's the easiest one to find. Can anybody tell me what the y-intercept is? C. There's the y-intercept. 0, comma, C. So you write the y-intercept as 0, comma, C. That's the y-intercept. Whatever C is, that is the y-intercept.
What is
Line of symmetry, domain, range, increasing and decreasing values. So hopefully all of you will be able to get the y-intercept. I hope. Always see. Question. Well, what about all the other stuff? Well, the completing the square will give you 2, 3, and 4. The quadratic formula will not give you 2, 3, and 4. The quadratic formula only gives you 2, number 2. Now, if you use other variations of the quadratic formula, it will give you 2 and 3 and 4. And then once you have got the first 4, you sketch the graph, and after you sketch it, you should be able to find 5 without any problem. Now, to find the x-intercepts of a quadratic equation, you first learn how to factor. You learned how to factor a quadratic equation by using the reverse what? FOIL. Y'all remember doing that a long time ago? And then you had the shortcuts. There were 5 shortcuts that you could use to find the x-intercepts. And then there was the quadratic formula, which was drilled into your head in high school because they did not want to teach what? Completing the square. Or some teachers don't like to teach completing the square. Now, I'm not going to focus too much on these. I'm going to focus on this one because you're going to need it in calculus, whether it's business calculus or first calculus, whichever one you take. And the vertex, what is the vertex? Well, let's look at a parabola. There's your parabola. The highest or lowest point, this is not the highest. When it's opening upward, it's the what? Lowest is your vertex. The highest or lowest point is your vertex. If you've got a parabola going this way, here's your vertex. Line of symmetry always goes through the vertex. Line of symmetry means it's the mirror. In other words, the left side looks exactly like the right side. And of course, here's your x-intercepts. You find that. You used to find it by factoring our quadratic formula. Now I'm going to show you how to find it. If you haven't seen completing the square, you're going to see it in the next couple of days. Today and next Thursday, you won't come to class. Okay? Y-intercept. Self-explanatory. And then once you have those 4 points, you can sketch it and look at the increasing, decreasing domain and range, which domain for a quadratic is always going to be what? All those numbers, Hubert. That's right, class. Okay. So we're going to spend the next couple of days, today and next Thursday, we're going to spend on finding all of these and sketching it and finding the domain, range, increasing and decreasing. Now, it used to be that you did this. If you had this, x squared plus 4x plus 4 is equal to f of x. Alright, this is what you used to have, where you used to have y is equal to that. And you used to go, okay, well I can factor that. Let's see. X, 2, and 2, and that would be a plus, and that would be a plus. And that was the reverse FOIL. Remember doing that back in Algebra 1 and 2, or 102? And that's called the reverse FOIL. Pronounce it however you would like. And then you were taught the shortcuts. And the shortcuts, I'm not going to go through them, but this shortcut, look, this is shortcut number 1. And you take the square root of this term. A is equal to x. Square root of this term. B is equal to 2. And then plug x plus 2 quantity squared. And that was called shortcuts. And you'd learn those back in Algebra 1 and Algebra 2. Now that should be, you should be going to your, you should be saying to yourself, oh yeah, I remember that. Everybody should be saying that. Okay? Then you did the quadratic formula, which I'm not going to go through that. Because like I said, that's drilled into your head. Some people have a song for it. But you only need it whenever you have decimals up here. That's when you use the quadratic formula. In my opinion. I got an opinion like everybody. So now, you're going to learn how to complete the square. So I'm going to write down what you're supposed to do to complete the square. 1. Set y equal to 0. Or set f of x equal to 0. Why? Yeah, but why? Why do you do that? Why do I tell you to set y is equal to 0? We find in the X-Intercepts. And I don't care if you're in Marketing 101 or Business 101 or Trig 101 or Algebra 101. If you want to find the y X-Intercepts, you plug in 0 for y. Or your independent variable. I'm sorry, your dependent. Number 2. Make sure make sure a is equal to 1. Ax squared plus bx plus c. A needs to be 1 before you can complete the square. Now we're going to talk about some problems where a is not equal to 1, and that's later. I'm going to show you that either by the end of class or Thursday. 3. After you've done these two, move C. Don't ask me where to move it because it's on the left-hand side of the 0. If it's on the left-hand side of the 0, where are you going to move it? There's only one place to move it, on the right side. I love it when students go, where do you move it? 4. Add blanks on left-hand side and right-hand side. Now, there are different forms of completing the squares. Different forms of completing the square. I like to teach the 0 property complete the square. Some teachers don't teach it that way. Some teachers teach it all on the left-hand side. And I don't teach that way because it confuses students, in my opinion. So I teach this one. 5. And this is the most important part. This is the actual, I'm sorry, I'm going the wrong. This is the actual part of completing the square. Take b, divide it by 2, square. B divided by 2 and square. 6, fill in blanks. 7. Draw 2 arrows, and you'll see what that means in just a minute. Okay, everybody got those? Now, if you get confused, go back to this page of notes and go step by step. Because when we do a problem here, next Thursday probably, when we get into the more complicated problems, you're going to forget this and you're not going to do what I tell you and you're going to get confused. So go back to this page when we get to the more complicated problems. So, f of x is equal to, I'm just going to put a new one up here because I don't want to use x squared plus 4. I don't want to use that because that'll in some ways confuse you. I'm going to start with one like this. X squared plus 4x minus 7. Alright? Now why did I make that a 7? I made it a 7 because I don't want you to be able to factor it. And a lot of times, there will be times that you can't factor the quadratic. That's why you have completing the square. Completing the square has no restrictions on it whatsoever. It is the one that you always fall back on whenever you don't know how to do it. Problem is, people don't teach it. You know why they don't teach it? Because it is subject to make fractions. That's why. The math in completing the square is 7th grade and below math. First thing you do is set f of x equal to what? 0. Now, I'm going to set it equal to 0 here, but I'm going to turn it around because I like to have my quadratic on the left-hand side. So I'm going to turn it around. Okay? And now what's the next step? Now move what? Move C. X squared plus 4x plus blank is equal to 7 plus blank.
Are you just skipping step 3 because it's already equal 1?
Yeah, I guess. Yeah. Sorry. You're right. I made sure it was equal to 1. I just forgot. And I added my 2 blanks. And now, you take 4 divided by 2 and square. What's 4 divided by 2 squared? 4. And you put that 4 on both sides in the blanks. This is some hard math, isn't it? I'm going to take this guy and make it a little bit smaller. I'm going to move that over here. And I'm going to change it to red so you can remember. And I'm going to change that to red. Okay. Let me ask you a question. When you do completing the square, what will that always give you on the left-hand side? Shortcut number 1 or shortcut number 2, depending on what this sign is right here. So this will always give you shortcut number 1 or shortcut number 2. Now I'm going to go over, I'm not going to go over and do it, but I will write out shortcut number 1 and 2 for you, just in case you forgot it. Shortcut number 1 is A plus B, quantity squared, is equal to a squared plus 2ab plus b squared. And 2 is a minus b quantity squared is equal to a squared minus 2ab plus b squared. That's your two shortcuts. Number 1 and number 2. And of course that should be, you should be going, oh yeah, I remember those. So I'm going to highlight this. And I'm going to hit copy. And paste. Okay, so there's my problem. Take this out. Okay. Now, what does the next thing say? After we got to use shortcut number, oh well, I just did shortcut number 1 or 2. So that would be what? X plus 2 quantity what? Squared is equal to what? 7 plus 4 is, thank you class, 11. And here's where your 2 arrows go. The right one is solve for x. The left one is vertex and vertex form. Now watch what I do here because this is confusing to some people. So just vertex, to get the vertex, I take the opposite. And I love it when I say that because somebody goes, opposite of what? Well, let me ask you a question. How many numbers are in that x plus 2 squared is equal to 11? I see 2. 2 and 11. So, what do you think I'm going to take the opposite of? 2 and 11. And that gives me the vertex. So my vertex is equal to negative 2 and positive what? I'm sorry, negative 11. And if you remember, if it's attached to the x, that means it's the horizontal what? Shift. Horizontal shift. And positive 2 means 2 to the what? Left. Now, vertex form, you're going to bring this 11 over and set it equal to f of x. So this is your vertex form. F of x is equal to x plus 2 quantity squared minus what? 11. And this is your vertex, and this is what we call intercept form or vertex form, which y'all studied back in Unit 1. The horizontal shift and vertical shift. That bottom equation is the horizontal shift and the vertical shift. Sometimes they'll ask for vertex, sometimes they'll ask for this. So you need to know how to do both of them. Now I want you to solve for x. And yes, everybody should be able to do that. If you can't, then you're a failure. Everybody's here except for Mr. Case. So I might as well go ahead and do that. Pace, not case. Alrighty, that's done. Now, there's two ways to solve for x. One is called exact. Exact means leave in radical form. Leave exact means leave in radical form. And then there's approximate. Approximate means decimal form. But what I'm going to do is I'm going to take x plus 2 quantity squared is equal to 11 onto the next page, and we're going to do it both ways. So, exact form, leave radical alone. In other words, leave the 11 under the radical. Approximate means they want it in decimal form, meaning you take the square root of 11. And you don't have to use a calculator for that. You can find the square root of 11 real easy. And I'm going to show you how to do that. So, x plus 2 quantity squared is equal to 11. And I'm going to do the radical form over here. Exact, sorry. So, x plus 2 quantity squared is equal to 11. And how do you undo a square?
Wait, what happens to the whole setting x setting in the equation equal to 0 thing?
We did at the beginning. And I moved C and added blanks. Here's where we set it equal to 0. Right here. And then we moved the C right here, moved the 7 over, and the 4. 7 plus 4 is 11. And x plus 2 is equal to square root of 11. And what's x equal to? The square root of 11 minus what? 2. This is your exact answer. Another way to write it would be x is equal to the square root of 11 minus 2, comma, negative square root of 11 minus 2. That's another way of writing in exact form, because when you take the square root of a number, the square root of 4 is either positive 2 or what? Negative 2. Because negative 2 times negative 2 is positive 4. And positive 2 times positive 2 is positive 4. So each time you take the square root of something, you have to set it equal to the negative and the positive. And I'll just make a note here, that's a positive and a negative right there. So let's change that to red. And then put the positive right there. And negative. And now we're going to do it the approximate. X plus 2 squared is equal to 11. Square root of everything, and that's x plus 2 is equal to the square root of 11. And then I'm going to go over here, and we're going to find the square root of 11 by using interpolation. What is the square root of 11 between? Well, it's between the square root of 9 and the square root of what? 16. Good. Tell me what's in the middle of 3 and 4. 3.5. So all you got to do is find the middle of the other side, and you have 9 to 16 is what? 7? Half of 7 is 3.5, right? 3.5 plus 9 is the square root of 12.5. So if you take your calculator and you find 12.5 and take the square root of it, I guarantee you it'll be around 3.5. Why? Because you got the middle of the right side and you got the middle of the left side. And the middles equal each other. Well, we don't want 12.5, we want what? 11. So we got to do it again. That's why it's called interpolation. Not interpretation. Interpolation, it's an engineering term. I don't know what the origin is, but it means take half of half of half of half, and you eventually get what you need. So, what is between 3 and 3.5? 3.25. We find the middle here. Well, that's 3.5. Half of 3.5 is what, 1.75? So that would be square root of 10.75. Well, the square root of 10.75 is around 3.25, so I think that the square root of 11 is 3.3, around 3.3. But y'all can check me. X plus 2 is equal to positive or negative 3.3. Somebody take the calculator and take the square root of 11 for me. What do you get?
3.31.
It's a mirror. And I guarantee you there's somebody in here that has never been shown that. You don't have to raise your hand or anything, but I guarantee you somebody in here has never shown it. And you took 12 years of school. 12 years math. Now what? Just bring the 2 over. X equals positive or negative 3.3 minus 2. And here's where you use a little bit of common sense. What is, well, I'll just do it this way. X is equal to, and I'll put that positive or negative right here again. What is $3.30 minus $2? $1.30. That's one X-intercept. You owe $3.30. You owe $2. What's the outcome? You owe $5.30. And there is your 2 X-intercepts. Now you need to let that soak in for a moment, because what's going to happen is you're going to get home and you can't figure out how I got from here to here. So you need to make sure you highlight this positive and this negative. That positive goes here, and that negative goes here, and you have two equations. And you need to put a star right there because that's what you'll forget. Now, the good thing about the approximate is that you can graph the approximate. You can sketch it because you actually see the what? The decimals. With this, they usually don't want you to sketch it. Usually they just want you to write it in this answer, this form right here, or this form. They don't want you to sketch it. But I want you to sketch it. So most of the time I will want you to do this right here. Okay? So, let's look at what we have so far. The original equation was x squared plus what? 4x minus 7 is equal to 0, right? And then we had it in the form of f of x is equal to what? X plus 2 quantity squared. Y'all help me out. Minus 11. Is that the form it was in? So this form gave us the y-intercept. What is our y-intercept? 0, comma what? Negative 7, Hubert. That's right, class. What did this give us? Which is?
Negative 2, negative 11.
Good. And our x-intercepts are 1.3, comma 0, and negative 5.3, comma 0. And I want y'all to graph it. I mean, not to graph it because you only got 4 points. That's why it's called sketching. I want you to sketch it and draw the parabola. And then I want you to find the domain, range, all that good stuff. No, you can sketch it on just regular paper because you don't. This ain't to. It's not to be exact. All you're trying to see is what the parabola looks like. I'm going to explain it. Just hold on, because I want to explain it a certain way. Huh? Oh. What time's class over? Oh, okay. It's 15 till, right? All right. Y'all ready? And our y-intercept is 0, -7. 1, 2, 3, 4, 5, 6, 7. Our vertex is -2. 1, 2, -11, that's 7, 8, 9, 10, 11. 1.3, and 2, 3, 4, 6. So our parabola looks like line symmetry goes through the vertex. Domain is all real numbers. It always goes through the vertex.
How do we like put that into an answer?
Just draw a dotted line. Domain is all real numbers. Range is negative what? Negative 11 to infinity. Now, increasing values and decreasing values. I'm going to show you that on the next page. All right, on the next page, I'm going to redraw the graph, draw it a little bit bigger, and I'm going to exaggerate it a little bit. 0, -7, 2, whatever, there, and over here, and right here. Okay. Which way we read? Left to right. So whenever you're reading the domain, range, not range, because that's vertical, but whenever you're reading domain and increasing and decreasing values, you're going to read the x values from what? Left to right. That is the domain, the increasing, and decreasing values. What is the only thing that we look at the y-axis? What is the only one that we look at the y-axis? Range. So y'all need to write that down, because y'all are going to try to do the increase and decrease in values with the y-axis, and I don't know why y'all do that. The only one that should have y in it is the range. So what I want you to do is I want you to draw you a plane on this arrow right here. Okay, there's my plane. Now, I don't know how many of you fly. I don't. But there's two coordinates systems with a plane. What are those two coordinate systems? Altitude and what? Just regular, just going distance. I don't know what you call it, distance, I guess. Right? I mean, when you fly a plane, you don't just go up and down. That's a helicopter. I didn't say a helicopter. I said a plane. In order for you to have a plane in the air, you have to go very fast, distance-wise, in order for the plane to get enough lift to get off the ground. So that plane, unless it's a Harrier, that plane has to have what? It has to have X values in order for it to what? Go up, right? Again, the reason I'm showing you this is because the most important coordinate to a plane is the X value, is the distance. Why? Because if you don't have a runway, you can't what? You can't fly. So the Y values are nothing to do with increasing and decreasing. So you put your plane right here. Because why did I put it on the left? Because that's the way we read it. Now, what is this plane doing from left to right vertically? What's it doing vertically? All right. How do you show down as far as the sign? Negative. So, would everybody agree with me when I say that the plane's feel me? I done lost my plane. Went into the Devil's Triangle. What's it called? Bermuda Triangle. Bermuda. That plane vertically is going down. So from this arrow to the line of symmetry, what are my values doing? They're decreasing. Now what those minuses mean is that from left hand arrowhead, my Y values are decreasing as I go along X. My Y values are decreasing as I go along X. So X is the predominant coordinate that we're going to put down on paper. So my decreasing values are from negative infinity to what? Negative 2. You just read the y-axis. Negative 2. All right, let's get our handy-dandy plane. And what is our plane doing from the vertex to the right hand? What's it doing? It's increasing. So my Y values are increasing from negative 2 to what? There you go. Y values, put Y values right here if you have to. Now, that seems simple, doesn't it? It's simple if you think about the plane. But when you start trying to do it without the plane or the thinking of the plane, you're going to start reading the y-axis and you're just going to start doing problems. Now,